everyone. Welcome to our channel Euclid Mathematics. We have started lecture series on CSIR NET SET Gate and other competitive exam. So within that I already explained plenty of the videos on my channel. So if you are interested to see this previous year question, you may refer my previous year question and the topic from my playlist. Now in my today's video, I'm going to explain to you all one of the previous year question from CSIR NET exam, which is completely based on a partial differential equation and a Green's function. Okay, so to about a Green's function, I already uploaded plenty of the videos on my channel. Okay, so you will get the ample of the information on my channel about Green's function. So you may refer this video. I already explained properties of the Green's function. Some examples depends on the Green's function. So if you wanted to go for detailed understanding of a Green's function, refer my previous videos. Now in my today's video, I'm going to explain to you all first of all the question, and after of that short trick to solve this question in our exam. Now let's get started today's question. Here in our question, we have given Green function g of xt of a boundary value problem. Okay, so here we have defined first of all the boundary value problem here, which is a d square y by dx square double differentiation minus 1 upon x divided by dx, which is equal to 1, and a boundary conditions are also given, y of 0 which is equal to 0 and y of 1 which is equal to 0. Okay, so this is our boundary value problem given in our question. Okay, so you need to identify which one is the boundary value problem, which one is the Green's function. Okay, so along with that we will get in question like a Fredholm integral equation or Volterra integral equation. That time you also need to understand how can we convert it into the boundary value problem. Okay, so now here Green's function also given g of xt, which is f1 of xt, f2 of xt. Okay, when x lesser equal to t lesser equal x. Okay, so we have Green's boundary value problem, and the format of a Green's function that we will get after solving this boundary value problem here is g of xt, and we have given 4 options. We have to figure it out which one of the option is correct. Okay, now you may see this is a question from 4.75 marks part C question. That means we have multiple answer correct. Okay, so for identify which one of the correct, we have to apply some of the trick, because now see here if we apply the regular process and steps of Green's function, that what we have to do, first of all we have to check whether Green's function exists or unique not. For that we have to check whether the solution is a trivial or not. So if trivial solution is there, then you have to move further. Non-trivial is there, again there is a problem. Okay, once you get the Green's function exist and unique, then you have to move for finding the values for Green's function. Okay, so you have to find out g of xt as a Green's function, and there you need to find somehow constants like a1, b1, a2, b2 which exist in our Green's function. Okay, so for finding these constants you have to apply more further steps, okay, for their differentiation and so many things. So it will be time taking. But if you understand or if you understood group properties from Green's function, so there are some 2 to 3 important property that can say that first property, it says that Green's function is a symmetric. Okay, if symmetric means if we have g of xt as a Green's function, then we can write a g of tx also. Okay, so this is the symmetric property. So Green's function is always symmetric. This is the first property. Green's function is always need to be a continuous. Okay, so this one is very much important property. Green's function is always need to be a continuous, and this is a symmetric. Okay, so this property need to know, or more further there are other properties too, but these only 2 property very much important for all today's example. We can solve this example 2 way. One is a regular way that I already explained in my previous lecture, but as I felt that you are familiar with the regular process for finding. Now this example we will take as a short trick or shortcut way to solve this big Green's function solution. Okay, now let's get start our solution. I will explain to you all how our options are coming true. So as we know, Green's function is a continuous as well as symmetric. So we have to check symmetric property in our option. Okay, symmetric means we have to check whether f of xt which is equal to f of tx or not. So wherever f of xt which is equal to f of tx exists, then we say that Green's function, which is the Green's function of our boundary value problem. Okay, now here we have first option, second option, third option, and a fourth option. Okay, so check out which options are symmetric and which are non-symmetric. The option is a non-symmetric, that means it is obviously not a Green's function. Okay, if symmetricity not hold, then it is not a Green's function. So you may, here we can check minus 1 upon 2 under bracket t minus 1 t into 1 minus x square. Okay, this is the f1 of xt, first function of Green's function. Okay, that is the f1 of xt, you will get it in Green's function, and this one is the f2 of xt. Okay, so these both need to be a symmetric. So you may check here minus 1 upon minus 1 upon 2t. So here the term of x which is not there, xt which is equal to tx which is not there, because of that symmetricity property discarded here. Okay, so here we can see that here we have t, we have x square, we need here t square. Okay, and 1 minus x square doesn't matter, it is same here. But the first option which says that Green's function which is not symmetric here, so we easily discard this first option because symmetricity property does not hold. Okay, so similarly, if we apply symmetricity property for the second option, so here we can see minus 1 upon 2x, minus 1 upon 2t. That means f1 of xt which is equal to f2 of xt which hold xt which is equal to tx as a symmetricity property. Minus 1 upon 2x is equal to minus 1 upon 2t. So t square here, x square here, 1 minus x square here, 1 minus t square here. That means we have f of xt here which is equal to f of tx, f of xt which is equal to f of tx. This property hold here. Okay, so if f of xt which is equal to f of tx, then we say that Green's function is a symmetric. Okay, so second option which might be true, we cannot make option true but might be true. Okay, so it is a we may call it as a correct. Okay, so second one here. So let's check option number third, can it be symmetric? Minus 1 upon t, 2t, again minus 1 upon 1 half into t. So this is x square here, t here, 1 minus x square, 1 minus t square. So symmetricity is not hold here. Okay, f of xt which is equal to f of tx does not hold. So option third also wrong. Now let's move for the option number fourth. Fourth option, it says that f1 of x is equal to minus 1 upon 2t x square into 1 minus t 1 minus t square bracket complete, and f2 of xt minus 1 upon 2x t square into 1 minus x square. Okay, so here we can see that the symmetricity also hold here in option number fourth. Okay, so minus 1 upon 2t x square into 1 minus t square and t square into 1 minus x square. Okay, so symmetricity hold for option second and option fourth. So option first and option third, these two violate the property for symmetricity. So if first and third violate the property for symmetricity, we discard these first and third. Okay, so discard first and third two options and remaining second and fourth which will be the correct. Okay, because symmetricity always hold for the Green's function, so we say that the second fourth is correct. And if you want the detailed solution, you may check here in downside. Okay, so trick we applied here, Green's function is always symmetric and as well as continuous. Okay, we may apply it for the multiple choice. Okay, single choice you have to check. Okay, g of x2 is equal to g of tx, hold here only 2 fourth and second fourth which are the correct option. Okay, so here 2 and 4 option number 2 and 4 are correct. Okay, so here it is the correct answer, 2 and 4 are symmetric. I hope you all have understood my today's lecture, which is completely based on Green's function and the properties from Green's function. So already I explained plenty of the videos on Green's function, the topic, detailed understanding, and previous year more questions you may find into my channel. Okay, you may check it into my channel, already plenty of the videos are there. So I hope you all have understood my today's example. It is completely based on Green's function. Okay, so thank you everyone, thank you for my today's lecture.